Hey everyone, happy Friday. Welcome to our last, really hard hitting review. We're still going to review for the state test, don't get it twisted, but this is our last one where we're really hitting it hard. So that's exciting. I'm excited. You should be excited. And I left a pretty easy slash, I think it's fun one for this beautiful Friday. So let's dive into it. We're talking about natural hazards, which we remember are those crazy events that are going to change or impact human life. So this is like your tornadoes, your hurricanes, your earthquakes, all that good stuff. Now we remember that some of them are predictable, still can't spell, meaning we know ahead of time that they're going to happen. So we have ways to see them coming before they actually hit. And there are different pieces of technology that we can use to actually predict those natural hazards, or even the ones that we can't predict after they happen, we can study them based on these different technologies. So that's what we're going to talk about. Now, to be honest, we do pretty well with natural hazards, and most of this is stuff that I'm sure we remember. So I'm going to kind of zip through this one. So if I'm going way too fast, hit that pause button, please. So for each, I'm sure you recognize these slides. For each natural hazard, we're going to just do a little refresher on where they occur or where they actually happen and impact human life. And then, are they predictable? Yes or no? And then, what is the technology that we use to study these natural hazards? So this first one, earthquakes. We know that's when the earth or the tectonic plates tremor or shake when those plates actually move. So these are going to occur more along plate boundaries, which we call fault lines. So anywhere where you have your convergent, divergent, or transform boundaries, that's where you're going to see more earthquakes happening. So we have a big fault line right around the coast of California over there. So they get a ton of earthquakes. Causes people to lose their life, sadly, and of course destroy property. If the earth shakes, buildings can definitely collapse. The sad thing, really sad thing about earthquakes is they are not predictable at all. We have no idea when they're going to happen until they happen. They just kind of hit. And the technology that we use to study the impact an earthquake has is a seismograph. And remember, the word seismo means earthquakes. Think earthquakes when you see seismo. It's talking about tremors or shaking of the earth. So here's a seismograph, just a needle that literally moves when the earth moves. So the bigger the scratches on the paper that it leaves, the bigger the earthquake. And then we use the Richter scale to measure or to label earthquakes. So the bigger and more crazy, massive the earthquake was, the higher the number on the Richter scale it's going to be. And the highest, I believe, is a 10. So if you have a 10 on the Richter scale, oh my gosh, that's a big one. Next, we have volcanic eruptions. These are kind of predictable, kind of not, because we're still going to use seismographs to study the impact of volcanic eruptions. So volcanoes, what they do is when they erupt, it's usually caused by an earthquake. So the earth will shake and it'll cause that volcano to erupt. So in that way, they're not predictable, but we are able to notice beforehand that the volcano is kind of acting a little weird. So it's going to release a bunch of smoke and release some gases into the atmosphere that it normally doesn't. So we know, this volcano might erupt, so that's not good. They occur at those subduction zones, which we know is when the oceanic plate sinks underneath that other plate, because that's where those volcanoes actually are formed. Good stuff. Next, we have flooding. So that is when you have a river or an ocean or lake or any big body of water fill up to the point where it overflows and you have water in places that you don't want water to be. Flooding is predictable because it usually happens after a large amount of rainfall, which we see happening, right? We know when rain is going to come, so we can tell if a flood is going to likely happen. The technology we use, this isn't really to study floods, but it's really to prevent floods. So that's going to be our dams or our levees, which a levee is just like a really long dam in a way. That's what the Sardis Dam is for. So Sardis Lake doesn't overflow. Prevents flooding. Pretty nice. So of course, it happens near big rivers or waterways, like big lakes or ponds or oceans. And of course, when there's a flood, You're going to have some property damage. You can't have water all up in your house, and also loss of farmland. So if it goes onto a field, it can ruin all the crops and life, of course. Then we talked about hurricanes. Hurricanes are totally predictable. We always see hurricanes coming before they hit. They don't typically just happen, right? We usually have sometimes a couple of days or even weeks to predict when a hurricane is going to hit the shore. So hurricanes, again, are those big storms that form over the ocean and move in a circular motion and spin and spin and spin toward land. So they keep spinning until they crash onto land where they eventually die out. So they're going to happen near typically warmer water. So that's going to be like near Florida or Louisiana or even in Mississippi down there at the Gulf Coast, right? So, of course, all that water has very similar impacts as flooding. So it's going to literally flood houses because that's a lot of water being thrust onto the land. So loss of property and loss of life. It's just not great. And the winds are also super, super fast. So that's going to damage some property too. So like I said, yes, they are predictable. The technology we use, well, this right here isn't really a technology. This is just how we study hurricanes or measure them. So we measure them using the Saffir-Simpson scale. So the Saffir-Simpson wind scale is just how we categorize how big a hurricane is before it hits the shore. And we measure that by the speed of the winds. So if the hurricane has winds that are moving at 120 miles an hour, that is between these two numbers. So it is a Category 3 hurricane. And gosh, even a Category 1, those winds are moving very quickly. So no thank you. But the technology we use to actually see them coming are going to be satellites up in the sky. You can take pictures of the ocean from super far away and look how massive that is. So we definitely see that thing coming. That is hard to miss. Okay, next we talk about tornadoes. So tornadoes are kind of predictable. And if you remember us talking about why are they kind of predictable, we know when we can study and know when we are going to have a large amount of wind and rain. However, if you have a tornado like this that actually spins and touchdowns onto the earth, we have no idea where or when this cloud of wind is going to actually hit the ground. So we can know that, okay, a tornado is going to be in the area, but we don't really know where or when it's going to hit. So that's kind of scary. So the technology that we use to study whether a tornado is coming or not is weather radar, which you see on the Weather Channel. I know we're a little young for the Weather Channel, but if like your parents or grandma or auntie or somebody still watches the Weather Channel, you see the Doppler radar. That's the fancy name for the radar that's going to be on the weather. So it shows like what precipitation is moving and in what direction, which is going to be a tornado, right? And we also, just like the hurricanes, will use satellites from the sky. Now, they typically occur in the middle of the United States, right in the middle of the United States. We call that tornado alley because it's nice and flat. So when it's flat, it's able to have a lot of wind move throughout the area. So you're going to see more tornadoes come through and touch the ground. Kind of scary. Then we talked about forest fires. That is when, like it says, a forest catches on fire. This happens when there's a ton of heat and like no rain. So a lot of heat and high temperatures are hitting these trees that are super dry, and it never rains to put out any little fires that happen. So a little flame can spark and spread. So kind of scary. And obviously, if it spreads enough, that's going to hurt the habitat of animals, and if you have a house near a forest fire, it's probably going to get destroyed and burned up. Kind of scary. So these ones are kind of predictable because if it's caused by, natural causes like just the sun being super hot, we can tend to know that that's going to happen. But if it's a forest fire caused by humans, so like if you just blow up something near a forest fire or near a forest, it can cause that fire to hit the woods and spread. So that one we can't really predict because usually that's an accident. So it just kind of happens and suddenly we're in deep trouble. Suddenly this is what our forest looks like. So it's not good. Really the only technology we use to, I don't even say study, typically just to watch the forest fire and see where it's going to spread is again satellite imaging. So we use those cameras way up in the sky to watch the fire spread, really. Okay, we got 2 more. Next we have tsunamis. I really like this one, and I feel like you guys like this one too. A tsunami is just a massive wave that's going to crash onto the shore. So this happens on land near the ocean, and what causes it is an earthquake. Actually happens underneath the ocean, and the waves come up and crash. So obviously a big wave crashing into your house is going to destroy it, and that's a lot of water, so that's some flooding too. Since it's caused by an earthquake, tsunamis are not predictable because we can't predict earthquakes, right? So no, they are not predictable. But the thing we use to measure tsunamis after they hit is this thing called DART, which is just an abbreviation for Deep Ocean Assessment and Reporting of Tsunamis. So basically, it's kind of like an underwater seismograph. So it's going to measure different movements of the earth and the plates that are on the bottom of the ocean to let us know, okay, an earthquake is happening. Get out the way. Last but not least are our landslides. They are typically also caused by earthquakes or when a lot of heavy wind or rain occurs, or even just gravity wearing down on a steep slope. So what happens is you have a very steep, like straight up hill or mountain or piece of land or whatever, and it all, like it says, slides down all at once. Kind of scary. So of course, if there's anything in this path, it's being taken out. It's being destroyed by that landslide. So no, they are not predictable because again, we use a seismograph to study them just to see, okay, what caused this land to slide? Was there an earthquake? Did the earth move? And is that why it came down, or was it another cause? So those are your landslides. All right, here is your cheat sheet. It's an okay one. It just puts everything into a nice table so you don't have to flip back and forth here. So you can just quickly see what is the natural hazard, what is the technology we use to study it, where does it occur, and what is the impact? So like what happens after this natural hazard hits? But then you just have 2 little independent practices. This first one, only 4 little questions. All you have to do is look at the map, and for each number on the map, tell me what natural hazard will likely impact this area based on its location. And of course, there can be more than one correct answer for this. So like number 1, we're talking about California, which we talked about up here. Where is it? Up here with earthquakes. California is sitting right on that fault line. So that's where you see a lot of earthquakes happen. So for number 1, I would say earthquakes. So just do that for each little spot. Think about its location in the United States. Is it near warm ocean water? Is it in the middle of the United States? What happens in those spots? And then for this last piece of independent practice, it gives you technology or a item or something that is going to be used to study and or predict a certain natural hazard. So just read it and then tell me what natural hazard is that thing going to predict or study or label or whatever. So like when I see DART, we know that that is the thing that is going to be used to study and measure tsunamis. So I'm going to type tsunamis underneath DART. And not all of them, but some of them could technically have more than one answer as well. So once you finish all of those, just do your exit ticket and then you're good for the weekend. And I will see you in person on Monday if you're in session 1. We've got this.